Alright, now we'll discuss a little bit more about the internet. As all you might expect, the internet is the most used network in the world, and it consists of various different types of networks, types of backbones, types of wide area networks all put together. It's managed by for-profit, non-profit, government, and non-government organizations. So pretty much everybody is involved with the internet. It's kind of a living, growing thing. Organizations use standardized protocols to communicate. TCP/IP is the primary protocol used over the internet for communications at the network and transport layers. And there's fewer controls over content and applications. So compared to a lot of other types of communication and a lot of other types of environment, there's very few controls over the internet. And that has its benefits and its drawbacks, as you know. Thank you. So it's important to understand that the World Wide Web is not the internet. What you do in your browser is not by itself the internet. The www or World Wide Web is about content, specifically hyperlinked content, and pretty much using the hypertext transfer protocol to send its communications. So it only uses a few ports in the TCP/IP stack, and the internet is really a transport mechanism that enables the www as well as other services like Telnet, like SSH, lots of other services, FTP secured FTP. The internet consists of all that since it's the transport mechanism and it's not isolated to www. Thank you. Now we'll discuss internet service providers or ISPs, companies like Comcast, like Frontier, like Verizon Fios. They're internet service providers. They connect the networks of their customers to the internet. So usually that's done by the generic term with a cable modem. The hierarchy of ISPs is broken down by size. There's tier 1, 2, and 3, and that's national, regional, and local, respectively. Thank you. And connections between ISPs. So historically, lower tiered ISPs purchase connections to higher tiered ISPs, and most interconnections between ISPs occur at the Internet Exchange Point, or IXP. So I would like to think that companies like Comcast subcontract to a lot of smaller companies that deliver their services, and that's probably the lower tier purchasing the higher purchasing connections to the higher tier. So that gives you an idea as to how the internet architecture is laid out. So pretty simple stuff. Thank you. Okay, remember that the Border Gateway Protocol, or BGP, is the standardized exterior gateway protocol designed to exchange routing and reachability information between different networks. So that being said, ISPs are autonomous systems that and share routing information, and they share that routing information using BGP or Border Gateway Protocol. Service charges are frequently involved. Higher tiered ISPs charge lower tier ISPs for data transfer, kind of like the big banks charge more interest to the smaller banks. Same kind of concept. And ISPs at the same tier typically do not charge each other. It's not in their best interest since they're at the same level. They don't work in competing markets usually. Therefore, for them to have the free flow of information at their level, it would be too much trouble, and it would end up costing too much for same tiered ISPs to charge each other. It's called peering, and it's one of the primary reasons for IXPs. So that's the basic idea between the internet architecture and the way the layout is. Thank you. The point of presence concept is different between different types of ISPs. For cable companies like Comcast, a point of presence could be based on existing contracts and deals with certain cities, and can be more metropolitan based. Certain cities allow Comcast, certain cities don't, so their point of presence could be based on a geographic area. In networks such as AT&T Uverse, it's based on the signal strength is based on the distance from the central office. So the CO or central office has to be somewhat close. So this kind of feeds into the point of presence theory, and the point of presence connects the rest of the ISPs, and authentication is performed at the point of presence. In other words, your authentication happens at their site, not on your cable modem. Otherwise, it would be way too easy to have free internet. Thank you. So, as we know, some organizations use WAN technologies to connect their ISPs together. However, common broadband technologies to connect to ISPs include DSL, cable, fiber to home, and WiMAX or wireless. Thank you.
This slide goes over the digital subscriber line, or DSL. Please look this over real quick. I don't want to spend a lot of time on it. I think DSL is a technology that is starting to subside. So it's good to know, but it's not something I want to focus on too much. Thanks. Bye.
Now we'll discuss cable. It's an alternative to DSL offered by the cable companies. Most cable ISPs use hybrid fiber coaxial, or HFC, networks with coaxial cables in the customer premises. So on the wire, they're using a hybrid fiber coaxial cable. And cable networks are multi-port, which means they're shared, while DSL is point-to-point. So cable networks are multi-part, meaning there's shared bandwidth and there's potential security issues. So keep that in mind. Thank you.
Data over Cable Service Interface Specification, or DOCSIS, is a set of standards used by the cable ISPs, like Comcast, like Time Warner, etc. The first link gives a really good description of what the DOCSIS standard is, and I would ask you to read this. This URL will be in the description. It will also be on the PDF slides. In the next link, I would like you to look at that as well. That will make a lot more sense to you as we go on. And ask yourself, is DOCSIS a de facto standard? Is it? You tell me. We also need to understand that the cable modem at the customer premise are capped the bandwidth at a maximum rate specified by the contract. So the contract that you have with your cable provider is usually the capping point at the cable modem. Thank you.
In this video, I'm going to teach you about the different types of fiber to the home architectures that are used and the differences between them. Now, with fiber to the home, there's only two types of architectures. Those are point-to-point networks, which are Ethernet-based and active Ethernet network, and you get point-to-multi-point networks, which are usually passive optical networks. Basically, the difference between the two is that with passive optical networks, you are sharing resources and equipment, fibers, the thing that broadcasts the signal and whatever. Whereas with the active Ethernet networks, you have a dedicated link to your service provider's equipment. You're not sharing resources and you're not competing for bandwidth, at least to the switch. So let's start with passive optical networks. You get different types. You get GPON, EPON, and BPON. GPON being gigabit passive optical network, Ethernet being Ethernet-based passive optical network, and BPON, which is broadband possible network. The BPON one is a legacy standard. The only ones you're dealing with are GPON and EPON. But from they all are based on the same sort of systems and principles, and I'll explain how that works now. With the passive optical network, at the exchange, wherever this equipment is housed, you get what is called an optical line terminal. That's just a really expensive laser, which you're then sharing with up to 32 people. So how it works is you go from the optical line terminal, and either at the exchange or in a roadside street cabinet or a manhole, there'll be a thing called a splitter. And a splitter is just really a beam splitter or glass prism. If you remember from science in school, you probably have seen that picture of a prism where light enters the one side and different colors come out the other side, and that's exactly how it works with fiber to the home. We're using a beam splitter to broadcast that light signal with up to 32 people, and it will branch off, and it's just one single fiber that goes to each unit, and inside we'll mount a unit called an ONT, or an optical network terminal, which basically allows you to access the fiber network. It's normally, think of it like a modem. It's just the thing where you can plug in a normal router that you can get off Amazon or Maplin or wherever the hell you live in the world, and you can use Wi-Fi and whatever. That's how it works. So you have an optical line terminal at the exchange wherever the equipment is housed. It's then split using a splitter, and then it's broadcast out, and that's how it works. The disadvantages with PONs is that you are sharing resources, and as a result of that, at peak times you will notice a drop in your bandwidth, your broadband speeds. It's not going to be anywhere near close as what VDSL or DOCSIS or cable would be, but there will still be a noticeable drop. The other thing is, from a security standpoint, you are basically broadcasting your data to everyone. The way that this is mitigated is that the traffic to your thing is encrypted. So only your optical network terminal will be able to read it. So it's scrambled for the other ones. And then that's how it works. It's generally cheaper, again, because you're sharing resources, so there's fewer fibers. That means there's less splicing and less labor, and that all adds up, and that's why, the incumbent telecoms operators, they love these things. They're not very good, though, if you have what we call an open access network, basically that there are different internet service providers on the network, but there are providers who are able to do it using PONs, and yeah. But the main standard you need to be aware of, you can go anywhere in the world, is GPON. It's Gigabit Passive Optical Networks. If that's the only name you remember from this, it's just, when you see this, think GPON. For businesses and whatever, they use PONs that have much higher bandwidth, but yeah, we're not going to discuss this in this video. So the second type of network is what is called an active optical network, and these are generally Ethernet based. By that I mean there's a switch, which is an Ethernet switch, and it has little ports on it where you can plug in each subscriber's fiber link, and that gets plugged into a little device called an SFP, and it's usually either one or two fibers. We've been able to get it to one fiber, so we can send and receive on the same fiber, just like you get with PONs. We normally have a spare in case you have a cottage or a flat sharing arrangement or something and you want a physically separate line, but yeah, you can normally, it will only use one fiber, but it just depends on the system, two or whatever, but using one fiber, it cuts down the cost. So you have the switch and everyone's connected into it, then it goes from there. Whether it, the switch is either at exchange or wherever you're housing the equipment. You have a multi-fiber cable. So again, each one has their own individual fiber, and then from a street cabinet or a manhole, you basically branch out into the homes. There's no like splitting or any sort of thing from that. And at the home is a CPE. These terms are used interchangeably, but it's the exact same thing as an optical network terminal. Just allows you to access the fiber network. As I said, you have dedicated bandwidth to this thing. So if your neighbor's streaming high definition porn in the evening, you will not see really that much of a drop in speed. I mean, normally you get speeds that are actually higher than what you're actually paying for. And if it is to drop, it will drop to the speed which you are getting. Yeah, the other thing, the security is much better because you're not sharing the links, and yeah, the having dedicated bandwidth. If you had to choose a network, this is the best sort of network in terms of troubleshooting and that sort of stuff. It's a lot easier, a lot better bandwidth management and that sort of thing. Yeah, there's not much else that I can think of to say. But yeah, the only thing is it's more expensive because it's more fibers, more resources, more equipment, more ducts underground, that sort of thing. But yeah, that is it's the best sort of architecture you can go for. So that's really all I want to say. I hope you found this video informative and I haven't just been waffling on the whole time. If you have any questions or comments, please leave them in the description, in the comments section below, and I'll have a look at them and try and address any issues if there are there. If you like my videos, please subscribe and I'll try and upload more as soon as possible. But thank you again for watching and goodbye.
Now we'll discuss wireless or WiMAX. It's based on the 802.16 standard. That's the wireless standard for fixed and mobile. It's similar to 802.11, but with a much longer range. It's one implementation of 4G mobile wireless, so that's all of your smartphones out there. The maximum theoretical range is about 30 miles, and the maximum theoretical data range is about 70 megabits per second. The Wi-Fi standard includes possible two 66 gigahertz frequency bands, but only 2.3, 2.5, 3.5, and 5.8 gigahertz bands are used in North America. That's usually based on regulations from the FCC. Thank you.
We'll discuss some other types of wireless now. The LTE or LTE Advanced stands for Long-Term Evolution. You're probably familiar with seeing this with your cell phone connections and your smartphones, whether it be an iPhone or an Android. Also, satellite is a type of wireless. It's primarily used by rural customers. There are issues of high latency and low data rates, and it's two-way versus one-way communication. So, thank you. Now let's talk about internet governance. So there's not one single organization that governs the internet, as it's been put together piecemeal over the years. However, it does get guidance from the Internet Society, or the ISOC. Some entities within the ISOC include the Internet Architecture Board, the Internet Engineering Task Force, the Internet Engineering Steering Group, and the Internet Research Task Force. Internet governance also comes from the Internet Corporation for Assigned Names and Numbers, or ICANN. You may have heard about this recently. There was quite a bit of controversy about ICANN a couple years ago. The ICANN organization was strictly run by the United States government, and names were tied to IP addresses by the US government and by American entities. And this was something that didn't get a lot of attention. Pretty much any kind of name that was requested was granted. I mean, it's a nonprofit organization. However, I believe it was 2015, but don't quote me on that, Barack Obama opened this up and made this an international organization. So there was some controversy over that. So far, I haven't heard anything saying that there's been a problem with the new way, but it was done to encourage world governance and world cooperation within the internet. So also the Internet Governance Forum and the International Telecom Union have quite a bit of influence as far as the internet governance is concerned. Thanks.
Now we'll discuss the issue of net neutrality. So the issue of net neutrality has to do with internet service providers such as Comcast throttling down speeds of services like Netflix unless they pay a premium rate. So basically the idea of net neutrality prevents an ISP from charging for speed and putting preference over one type of traffic as opposed to another. So this does have the ability to create monopolies. This has the ability to keep smaller companies from having a chance, where the internet was supposed to be, the concept of it is that it's supposed to be free, but at the same time, by making regulations preventing ISPs from regulating their speed, you also have a internet freedom issue. So it's a tricky issue. I know what side of the issue I'm on, but it is a governance issue. And since this book has been written, the FCC has passed its version of net neutrality, and it's out there. It's not a fun read, but it's out there, and a new net neutrality law has been passed. Thank you.
And since that new law was passed, it's also been repealed, as you all have recently heard. So the issue of net neutrality continues. Right now, we do not have net neutrality, but we did for a little while. Thanks.
Now let's discuss building the future internet. The internet continues to evolve and improve, often through a combination of commercial and government research projects. I put this Internet 2 bullet point in here for the future internet. I would actually say this is the present internet now. We've been doing packet traces with Wireshark for this entire term so far, and I know you've seen the Internet 2 as the protocol listed. So it was created by the U.S. National Science Foundation, and the project was started in 1996 and continues till this day. And it includes many, many new developments each year. Thank you.